Okay, the last part of this video is just to show the assembled parts. Here's my 16 gear tooth gear, and then here's my 18 tooth gear. And I tossed a 2-inch hole in each one of them simply to make it easier to use my assembly components. Where I have mechanical, I can use gear, and I need to pick a ID or circle on there to describe what I'm using the gear for, and I also use the number of teeth to set up the ratio. So when I, having built the gears, made the profiles, and now I've assembled them, you can see how the envelope profile matches on its sister gear on both sides. Now this isn't really an accurate way gear teeth really work, because when we've ordered gear to gears where I've worked before, you would always have some sort of clearance built in, and you need to have that in there for it to function correctly. But when you design it, you typically just design the gear to size, and then you ask for that in the um, when you order the gear. Okay, but if I go and take this gear and I start going through the envelope, you can see how it meshes from tooth to tooth, just the way it should. So the involutes are good. We could actually have a little bit more fillet down in here. There's an 1/8 inch difference between these two, so we could go a much larger fillet in there, and that would increase the tooth strength. The mating condition in here is a nice feature in this particular software, similar to SolidWorks, where you can mesh it and it will move both gears in the same ratio. I hope this was helpful for anybody who was interested in how to create an envelope gear. All the information I got were from places like my textbooks from college, um, and places I could surf on the web. I hope you enjoyed this, and please have a good day.